This project is an initial step toward automated and thermal-based monitoring of light fixtures and air terminals in a building. The tool is written in Python and provides the possibility of processing up to 2 thermal images captured from a ceiling of a room that contains light fixtures and air terminals. A GUI is provided for the user to be able to interact with the tool, so they can browse for the thermal image. This is a sample thermal image from a ceiling that contains lights and air terminals. So for detecting the objects, the user is given the chance to detect the objects separately, since they may need different types of analysis. For example, first assume that we want to select the lights. Then some image processing algorithms such as Gaussian low-pass filtering, canny edge detection, and some clustering algorithms are processed to detect and locate the lighting systems. For example, here you can see 3 lights are detected and located on top of the thermal image in the GUI. Also, the detected edges by the algorithm is shown right beside this picture. However, since the algorithm may not be as accurate as we desire, the user is given the possibility of modifying the detections. Although here all the detections are correct, but assume that they are not and we want to modify them. Different types of modifications are possible. For example, I may want to delete this wrongly detected light, or I may want to add a new light in a new location, or I may want to change the type of the light to a terminal. So all these possible modifications can be done, and now my modified version of the detection has only 2 lights. So after I'm done with the modification, I can see the temperatures of the lighting systems. The next step is to detect the terminal. As you can see, I have both the actual terminal and the one that we modified in the previous section. Assume that I want to change this wrongly modified air terminal again to the light. So now I can change it and I have 3 lights and 1 air terminal. Okay, you have the possibility to see the temperature of different components differently. The next step is to select the image, the second image. So this is another image. You can pass through the same process. For example, here I select the air terminals to be detected first. The same image processing is passed, and the air terminals, 1 air terminal is detected. Okay, I don't want to modify it. I want to see the temperature. I want to detect the lights. 2 lights are detected. I don't want to modify it. At the end, when you are done with all your modification, observation of the temperature, etc., you can export your data to a CSV file. As you can see here, the light fixtures, air terminals, along with their coordinates in different images, and the temperatures are exported that can be used for further analysis.